Good day, this is Ken Johnson. I'm here to present a technical paper on IQALUIT Nunavut sewer main replacement in permafrost. I would like to acknowledge the co-authors on this paper of Ian Crawford, Simon Pleward, Mark Lafleur, and Chris Kuhn from EXP Arctic, as well as Shane Turner and Jason Harasimo from the City of Iqaluit and Richard Seahole from Collier's Project Managers. The terrain around the City of Iqaluit is permafrost. It's generally underlain or consisting of silty sand, sand, gravel, and boulders, varying from 0 to 18 meters thick. The depth of the permafrost thaw, or the active layer in Iqaluit, is between 1.0 meters and 1.8 meters. The groundwater is also quite high in many sections of the community, and there's a lot of ice lenses found. Iqaluit experiences 8 months a year when the average daily temperature is below freezing. The warmest month in July has an average daily temperature of 8 degrees C. January has an average daily temperature of minus 26. The project we're concerned with is in the lower base area of Iqaluit, which is shown on the site location map. This is part of the original airbase construction of Iqaluit back in 1941, which was part of a series of airfields used for ferrying aircraft from North America to Europe. The original level of service in this area was trucked water and sewer until 1985, when pipe services were constructed, which included the pipe services from AV 205 to AV 211. The picture in the lower right part of this slide shows the catchment area of this trunk sewer replacement. The municipal guidelines for Iqaluit state that there must be a minimum of 3 meters cover over the grade. This is intended to reduce the active layer and the thawing dynamics acting on the pipe. The factors that are playing in, of course, at this time are climate change and associated impacts within the active layer, which can further influence the stability of buried services in Iqaluit. The project areas you can see on the photograph on the upper right-hand side go from AV access vault 205 to access vault 211 along Mivik Street in the lower base neighborhood. You can see the access, a picture of the access vault on the lower right-hand column. The alignment of the sewer may be changed from the south side of Mivik Street, where it's currently, to the north side of the street. This alignment will allow for flexibility in the design and potentially a lower cost of construction. The geotechnical considerations. The terrain around Iqaluit is highly variable, with encountering bedrock or large boulders during construction, and this is not uncommon. But the other aspect of it is a fairly wet soil just because of the subsurface water system. You can see on the first photo on the right an excavation where you've got the existing water, sewer, and recirc water mains in a soupy mess. But what is maybe more interesting is the photo on the right-hand side, which shows one of these access vaults being installed below permafrost. You can see the level of permafrost, or in the active layer, as a white line that is shown on the side of the trench. So the intent is to get the sewer buried below the active layer. The lower base area of Iqaluit was originally a fuel storage depot back when the airbase was constructed. So this legacy fuel storage, and of course this becomes a need to potentially remove and remediate the work. This is a legacy from 80 years ago. The pipe zone considerations, as we've already talked about, is that there are ice-rich and silty soils can be encountered within 5 meters below the specified pipe base, so that over-excavation may be required to create a stable base. But as already been suggested, is that generally speaking, the preferred depth of pipe is probably closer to 3 meters, so that you're well outside the active layer, so that the pipe generally is stable. For wet trench situations, a coarser material such as a well-graded and well-rounded subgravel may be used to stabilize the trench. But you can see in the photo on the right-hand side the the pipe configuration where you've got the sewer main at the lower elevation, the water main and the water recirculation main at the higher elevation. All the pipe materials within the city of Iqaluit use high-density polyethylene pipe, HDPE. Generally speaking, the sanitary sewers from the mid-80s usually utilize an SDR45 or SDR60 pipe. However, there were serious problems with pipe crushing, so that Series 80 and Series 100 pipe has been used probably for the past 20 years. And of course, this pipe is insulated with a 50 millimeter urethane foam insulation, and you can see that in the photo in the lower right. As already noted, the water and sewer system in Iqaluit is supported by what are called access vaults instead of manholes. Access vaults are a insulated metal unit that accommodates both the water and the sewer system going through the vault. This provision allows for freeze access to the water and sewer system in case that any of the lines freeze up, but it also provides a point that heat can be extracted from the sewer pipe and it can heat the hydrant. You can see in the photo on the upper right-hand side is that there's a hydrant in this access vault, so that hydrant is actually freeze protected by the sewer line going through the access vault. An example of a rather complicated access vault as part of the replacement is in the figure on the upper right-hand side. So there's a series of water mains going through as well as the new trunk sewer. I mean, these access vaults are very robust and have certainly been developed with time. The original access vault installations were back in the 1980s. So for the construction considerations along Mivik Street, Mivik is actually one of the main streets within Iqaluit, so it will be a crowded construction area, which makes the project even more challenging in addition to the technical issues. So maintaining access to the existing businesses and other facilities along with overhead electrical wires, excavation to and across existing roadways, and managing the vehicle and pedestrian traffic is a major consideration, or was a major consideration in the design. There's a photo of Mivik Street in Iqaluit. So what was considered in the original design criteria was replacing the sewer in the original trench, and you can see this photo of a typical trench installation where you've got the sewer main, the water recirculating main, and service connections. And this can be, I say, a very busy trench. It was recommended, and the design did include the relocation of the sewer main on the opposite side of the street. So this will allow ultimately a more efficient construction and probably significantly reduce the construction costs, as well as allowing for not needing the provision for maintaining a continuous sewer bypass and a temporary water supply. The recommendations, recapping out of this design, were that the estimated sewer flows were completed to 2050 with a growth scenario of 3.4%. To address the anticipated sewer flows, sewer diameters are recommended to be at least 450 to 500 millimeters in diameter. To reduce the complexity, risk, schedule, and cost, the new sewer alignment should be constructed and has been constructed for the north of the opposite side of Mivik Street from the existing system. And to provide adequate sewer strength, freeze protection is recommended that a DR9 insulated HDPE pipe used, which has a 200 psi pressure strength, and it will have a 50 millimeter of polyurethane foam insulation, fiber reinforced plastic jacket wrapped around it. To service the legacy soil and subsurface contamination, it is recommended that a contaminant management plan be developed so that there are no terrestrial discharges. This project was publicly tendered in March of 2021. However, the bids, although the three bids were very close to each other, the lowest bid was actually $2.5 million over the budget. And the factors to explain this were, in simplicity, the fact that the winter storm in Texas basically took up or provided a competition for any insulated pipe, so a lot of the market was in short supply. The current project will probably be retendered in 2022, and it is part of a 4-phase plan to expand the trunk sewer in the city of Iqaluit. For more information on the Arctic, you can look to any of these websites. Ken Johnson is a senior planner and engineer specialized in planning and engineering for small communities and particular remote and cold region locations. EXP is a multidisciplinary engineering firm with 3,500 employees across North America. Thank you.